Hello, everybody. Get the headphones on. Do these things work? So I've never been in one of these silent sessions before. This is going to be a little disorienting. Hopefully it's fun for you. It's going to be fun for me. I got stories to tell when I get home. Hi there. I am Jim Carroll. I am a category leader with AWS Marketplace. I will be joined by the lovely and talented Dan McDaniel, who is the Chief Architect and Information Security Officer for Wizards of the Coast. And together we're going to tag team on the topic of traffic mirroring and how you can deploy traffic mirroring in third-party tools to detect network and security anomalies, improve your security posture, performance for your applications, all that kind of fun stuff. And I'm mindful that it is we're probably the last thing between you and a beer, because the welcome reception's right next door. So we'll hopefully make it fun, interactive, right? I'll let you know when there's a couple of good slides to take a picture on. If you got your cameras ready, there are 2 slides maybe that are worth pictures. I'll make sure I give you plenty of warning on that. Here's a quick view of the agenda. It's not going to be too deep. I'll be up here for a while to talk about traffic mirroring, what it is, why we're doing it, customer outcomes, third-party options, stuff like that. Then Dan's going to come up and give a real-world example of what a customer is doing with traffic mirroring and third-party tools to do exactly what we're talking about, detect anomalies from the network to security postures, all that kind of good stuff. Then I'll come back, we'll do a quick wrap-up of sorts. I'll give you some homework. There's a call to action. There's always homework when you come to a reInvent session. It's not going to be deep homework. It should be fun. And then you can go off to whatever reception you've got planned. How's that sound? Everyone good? Cool. What is traffic mirroring? So if you know anything about Amazon Web Services EC2 networking, if you come from a traditional infrastructure operations type of thing, if you're a network engineer on-prem, you kind of know that cloud networking is a little different. It's pretty opaque. There's a lot of abstraction. Traffic mirroring is essentially a virtual tap that will allow you to take packets and route them to the third-party tools of your choice. That's essentially it. We're taking packets from the Elastic Network Interface, ENI, within your VPC, virtual private cloud, hopefully these terms are familiar to you, and letting you do what you need to do for better detection of these packets. It'll give you deeper insight for content inspection, better visibility to threats and how you monitor these threats, and will also give your first responders a better ability for troubleshooting. If there is some application that's not performing the way you need it to, great. Now you can have better insight. Rather than going to the logs and parse out logs and go through weeks of logs, you could go right to the packets and get real-time information and remediate an issue. So that's traffic mirroring in a nutshell. But why did we even do this? Well, it's because customers wanted it. If you know much about Amazon Web Services, we'll say, Amazon, period, we'll say that we work backwards from the customer. So we talk to a lot of customers, and as I was saying earlier, if you're from a traditional networking environment, where are my packets? And what would you do with that packet? I want to be able to better detect network and security anomalies. Customers have been saying that they need to have this visibility so they can make better decisions on their security posture. They need to gain operational insights and make prescriptive decisions and improve that posture right away. They also want to be able to take these packets and better understand how they go about implementing controls. If you're in an industry or you're with a company with a lot of regulations, there may be mandates that you demonstrate that you're keeping logs, that you're keeping packets, that you have this information available to you. So traffic mirroring helps these companies better meet the mandated requirements they may have in a given industry. And lastly, I've already said it, but troubleshooting issues. If you've got an application that's just stuck in the mud, with traffic mirroring, you can make better decisions on where that choke point might be. Is there a hiccup in the EC2 network? Is there a hiccup in the application code itself? You could do a lot of this information now with traffic mirroring. And this is what customers have asked for, so this is what we're trying to deliver. And why traffic mirroring? Yeah, you used to be able to do this in the old days on Amazon EC2 if you deployed agents. An agent-based approach, still valid, and there are still companies out there that do agents for tools within Amazon Web Services. But now you're dealing with agent sprawl, and these agents go everywhere, right? Deploying an agent, EC2 instance after EC2 instance, how do you keep track of these? How do you refresh them? How do you manage agent sprawl? So that's one thing. Traffic mirroring simplifies the deployment of your third-party networking and security tools. Whether it's a virtual appliance that you deploy in your virtual private cloud, or SaaS that you subscribe to, traffic mirroring simplifies the deployments of these tools. Also, Traffic mirroring will improve your security posture. What do we mean by that? An agent is in the data space of your VPC. And if the data space is already compromised, the agent's going to give you compromised information. Traffic mirroring works at the elastic network interface level. It takes packets from the ENI, which isn't going to be compromised. So you'll improve your security posture by working with traffic mirroring tools. And lastly, agents typically are tied to a particular tool. Or there may be a partner, an ISV, that has several tools that work on one agent. But it's still kind of vendor lock-in. With traffic mirroring, you're not using agents. We're giving packets to you, and you could route those packets to the tools of your choice. So we'll show you later on, there's a good and growing ecosystem of partners that have tools that are traffic mirroring enabled, and now you'll better get a chance to take advantage of the best of breed tools out there in the market for whatever your needs are. So less vendor lock-in, more flexibility, pretty good stuff. So with that, what does traffic mirroring look like? There are three major components to traffic mirroring. There are targets, which is the destination for those packets. The filters, how you shape it. What do you want those packets to look like? Do you want all the packets? Do you want some of the packets? Do you want none of the packets? You can apply filters for this. And then the session. The session essentially takes all that information and presents it to you. Something you could do, information with, or you could put it to a third-party appliance, whether that's open source or third-party tool off of Marketplace, which we'll talk about more later on. That's really it. Those are the three components: targets, filters, and sessions. So let's take a little bit more of a look in targets. Targets, again, they could be one of two things. They could be an elastic network interface. Woo! An elastic network interface where you can make sure that you've got a VXLAN header. Traffic is set up to UDP port 4789, and you'll be able to use the elastic network interface for the target of your traffic. It's important to know that if you're using third-party tools, these tools need to be able to work with encapsulated VXLAN traffic. Most do, not a big deal. The other way to deploy traffic mirroring is through a network load balancer. And as a network load balancer, as the name implies, it's a load balancer. So this helps improve the resiliency and robustness of your traffic mirroring deployments. If you've got a traffic mirroring target set up in an AZ, and for whatever reason, that traffic mirroring target starts to act a bit wonky, network load balancer will take a look at that. It will route the traffic to a healthier target in a healthier AZ, and you'll be up and running. It's also a way to deploy a fleet of devices behind an NLB. It gives you a chance to do some scale with that. We'll have a little bit more information on that. And here's one of the slides that you could take a picture of, and it wouldn't hurt my feelings at all. There's a lot of information on traffic mirroring that you could get online. AWS, we've got tons of documentation on it, but the documentation doesn't present this information in such a pretty way. This is a nice cheat sheet. This is what the filtering look like. These are the filters you have, and here are the options within those filters. So again, you can download the docs and read it all you want, but this is a nice cheat sheet. And I think the color selection is just dynamite. I really like it. It looks good. Pops off the screen. And what does this all look like when it's in motion? So as I was saying, there are incoming packets and there are outbound packets. You may say, nope, I just want to take a look at the inbound ones. I don't want my session or my third-party appliance to care about the outbound ones. I'm just looking at the inbound ones. And that's an example right there. And if you got a cat, my cat loves this slide. Just keeps the cat busy. So looking good. That's a good one to take a picture of too, but you don't have to. It kind of paints the picture of what the inbound and the outbound trafficking looks like. As far as the format of the packet, here again, here's a good one. I'll just build it so you can take a picture because it's really not necessary to talk about all that stuff. Here's a bit more information about what the VXLAN capabilities and characteristics need to look like. This is for whether you're doing it on an ENI or whether you're doing it with the elastic load balancer, network load balancer in this case. So you just got to make sure that VXLAN encapsulated packets are supported by the tool of your choice, and you should be good to go. Okay, cool. Any packet over 8,946 bytes will be truncated. To date, that has not been a big deal amongst any of the customers that are deploying traffic mirroring. If it is a big deal, let us know. It's good information to hear, but it hasn't been that big of a deal so far. So The third component, what is a session? A session is essentially a source with a target and a filter. A session takes that information and presents it to you. That's essentially a session. Gives you the information you need to make the decision you need to make. The session is also pretty cool in that you could have multiple sessions. Now, even though we only copy the packets once, the target copies the packet once, that packet can be used in multiple sessions. And sessions can avail themselves of multiple different packet targets. So you can mix and match. This is kind of helpful if you wanted to take a look at your traffic and bifurcate it. If you've got some really highly sensitive traffic that needs the immediate recognition from a tool, you could route that traffic and give it priority to a certain subset of tools and take a different set of packets and move them to a different tool if you needed to do that. So you could make more of a judicious decision on which tools you use, why you would use them, when you would use them, and how you deploy them. So the session is where you would make those kind of decisions. There is a way for you to prioritize the decisions, and so that's right there. You give a session ID you give an ID number to your session, and it is in a rank of the lowest number gets the highest priority. It's a pretty typical deployment. Now, what do you actually do with the packets? So when I say you, I mean you in the room. The packets are available for you to do what you think you need to do, including using open source tools for IDS, IPS, or whatever else you're going to be using, a Suricata, Jask. I'm trying to think of other ones that do it, or leverage the Amazon Web Services Partner Network, APN. The APN partners, there are dozens of them that have built products that are leveraging traffic mirroring right now. And one way you could get to them very, very easy is through AWS Marketplace. And I'll get to that pretty soon. Or if you're a builder and you want to be brave and build your own analyzer, you could do that. But we're finding that most people aren't building their own analyzers. They're leveraging the third-party tools that are already on the market. Chances are, if you're working with on-prem capabilities right now, you've got tools that you want to use in the cloud. Or if you're new and you're just native to the cloud, you may be busy building your own application. You don't have to build and maintain your own analyzer. So use a third-party tool. And the third-party tools that are most tested and most available are cataloged on AWS Marketplace. AWS Marketplace is a digital catalog of software deployable in the cloud economy. And I'm with AWS Marketplace, so it's a lot of fun. We're an engineering function, actually. So if you talk to anyone about Amazon Web Services and how many of our services are there, there's over 160 services. We're going to be announcing a lot more tomorrow. AWS Marketplace is one of those services. We're an engineering function. We write code to hopefully build the next generation of software catalog for customers to easily find, try, deploy, subscribe to, and manage that subscription through the life cycle of that software, and for ISVs to modernize themselves. ISVs are wanting to sell to cloud-based customers the way cloud customers consume. Consume on demand. Consume hourly, monthly, annual if you want. In some cases by the minute, right? There are also multiple year contracts that you can leverage now through AWS Marketplace. We've got over 39 categories. These categories range in a lot of different things. You'll see 8 of them up there. These are kind of like the basic infrastructure categories. The networking category is the one that I own and manage. So it's super cool. Other benefits of AWS Marketplace is the software that you subscribe to from Marketplace, you can put asset tagging around it. So now you can put governance around who's using your software, when, and how. And also, because it appears on your AWS bill, you can take advantage of consolidated billing. You could actually now use your software spend off of AWS Marketplace and input it into AWS cost optimization tools to rationalize your software spend. So there are a lot of reasons to do that, including bring your own license. If you've already got a license to run something on-prem and that company allows for license portability, bring that license. Spin up the appliance off of AWS Marketplace. You know it's been vetted. You know it's going to work. Bring your own license. So that's pretty cool. And that's AWS Marketplace. Fun stuff. Here are a few logos. We usually refer to these as NASCAR slides. There are 2 slides with a lot of logos. Here's one. If you want to take a picture, I encourage that. And here's the other one. If you want to take a picture, I encourage that. Most of these ISVs are here at reInvent, and they'll have a booth at the expo. So if you have deeper questions about any one in particular, I'll back up just in case you didn't take the first picture. Go by the booth, ask some questions. It's good stuff. Okay, moving on. Okay, so how does a customer actually plan to use traffic mirroring? The best way to hear what a customer is doing is to have a customer tell you. And so that's why we have Dan McDaniel, Chief Architect and Information Security Officer from Wizards of the Coast, to tell you about traffic mirroring and what they're doing with it.
Thanks, Jim.
Oops, let me shake that. There we go. Thank you.
Everybody hear me okay? This is kind of weird for me. Hear me okay? All right, so my name is Dan McDaniel. I'm the Chief Architect and Information Security Officer of Wizards of the Coast. Everybody know who Wizards of the Coast is? Kind of be surprised if people here didn't. We are the makers of Magic the Gathering Online, Magic the Gathering Arena, Dungeons & Dragons. We have 30 plus years of basically analog gaming experience. We have IP covering dragons and orcs and all kinds of stuff, from planeswalkers to you name the game, including some of the Hasbro stuff, which is our parent company. So what we had is this huge wealth of analog games that have been very successful. And 3 years ago, our CEO said, we're going to go out to the digital market now. We're going to start moving in the space where people can enjoy our games through the mediums of iPads, iPhones, PCs, whatever. So the first foray we did out there was Magic the Gathering Arena, which is the PC game-based game for Arena, which is for Magic the Gathering. So as we started spinning this up, what I ended up with in my portfolio is about 8 different game studios making 8 different games. I got role-playing games, I've got MMOs, I got trading card games, I got dungeon crawlers, and I've got co-ops. So I have 8 different business units building things very differently. And we're doing everything at the cutting edge because that's what we do. I've got Docker, I've got Kubernetes, I've got Terraform, we've got everything that has anything to do with expediency. So as our studios are focusing on making these games fun for users, what we found is that the ability to secure them and to understand what's happening inside of these VPCs was very challenging. The reason being is by the time the tools we were using could identify a risk in a stack, that stack wouldn't exist anymore. They'd already reiterated, launched another one, and so the cycle of communicating just wasn't anywhere near what we needed to support all these games that we're doing. We literally would have full environments that would be overwritten, and all the appliances we'd put in there would be overwritten and no longer exist. Trying to build out an SDK or put an agent on the boxes was very challenging because the speed with which the game has to perform, as anybody here are gamers knows, is milliseconds is between life or death in some of these games, or winning a match or what have you. So putting an agent on machines, trying to get a Kubernetes cluster to spin up, have that agent spin back, give it register, get it up to date. Well, that cluster may or may not exist more than 2 hours. So by the time I get anything out of it, it's up and gone. We expand, we contract between 500 servers to 2,000 servers in a matter of an hour based upon demand. A feature release, a new card set, just explodes. And everything we were using, we really struggled with it. It also struggled with doing A/B testing. So A/B testing is where we'll literally run 2 different backends of a game with little different metrics, little different tools to see which plays better. And trying to get our vulnerability scanners and everything to work in that space was a continual challenge because they were just different environments, but literally on the same product. We also had a challenge with spinning things up in regions based on player performance. For example, one of our games we're building out on console is we want to be able to spin up that game closest to where the players are heaviest at, whether it be a region in the UK or Hong Kong or wherever, and not having our vulnerability scans set up in those things made it very difficult to work dynamically. So we're having a struggle getting the visibility at the level we wanted to. We're struggling keeping up with the pace of the games. And then from an operational perspective, we were having a little bit of struggle trying to understand how much money did I spend on an agent when the life cycle of a server is between 2 and 7 hours. But I'm paying for 1 license for a year. How does that work in the billing perspective? And we worked with a lot of vendors in that space, and it was very, very, very interesting. Now remember, we're building games across PC, console, mobile. Everything on the back end is completely different by game. So it's not like we could take a template and say everybody has to adhere to this. Everything is very unique and specific. So when we're getting the bills for our games, we couldn't quite quantify it to the value we were getting. We were getting, every time we'd spin up a license, we would get a bill from one of our vendors. It's like, there's no way this server doesn't even exist for 3 hours. How am I getting bills for a year? Then we got it down to a month. So what we're getting ourselves into is the inability to, A, predict the cost of a game, which in today's economy is critical, especially in a free-to-play game, right? Where your margins are narrow, it's based all off of feature sets. And the feature sets is probably one of the biggest challenging pieces. We deploy 5 to 6 times a day into our games. We have a CI/CD pipeline that's continuous delivery. And we couldn't predict the overhead these agents and SDKs would give us on these releases because we just couldn't test them fast enough. So taking that risk into the gaming environment made my games very, very unsettled, very unhappy. Trying to deal with security with games anyways is a bit of a challenge. But we had to make sure that we were able to address the impact of the game performance, how to reduce operational overhead, and then how much does this cost, right? I mean, that's, to me, in our environment, we build and tear down. Our motto is deploy and destroy. We probably do that 100 times a day, depending upon the game. So even if you find an issue, we would go back and the whole system would be gone, and we couldn't even address the issue at that point. So that was our challenge with the support tools that we had. 2020 Vision, I've been using that for 5 years now, and this is probably the last year I'll be able to use 2020 Vision. But so what I was looking for, and when ExtraHop met with me 2 or 3 months ago, I think it was, and said, hey, what if we could get you packet level visibility into what's going on in your games without needing an agent, without needing to put an SDK? I was like, I'm very interested. And so they walked me through how the VPC traffic mirroring works. So what traffic mirroring does for us, it allows us to have actually really detailed level of packet understanding between what's being sent between my servers, whereas a log will get me server A talk to server B or node A talk to node B, but it doesn't tell me what it said, which is what we need to know. Is there malformed packets? What's my troubleshooting within the nodes? So I get the visibility. It doesn't care about my scale. It doesn't even care the regions. As they expand this out more and more, it gives us more and more flexibility in that space. And what it really helps is when we start doing A/B testing, we get to the real critical behavior of the back end of the games, which has allowed us so far to be able to start finding anomalies and behaviors and hiccups. For example, we had an issue where one of our games lobbies would hang up after a bit. We couldn't figure out why, troubleshot, excuse me. And once we were able to go through and look at what the packets were, we were able to figure out exactly what happened. We had one node, one Kubernetes cluster, just wasn't behaving correctly across the environments. So give me the transparency where my team, my analyst team, could work in parallel with the deployment teams and not be a gate, not be that one that says, wait a minute, do you have the agents on there? Let's test it. Has really moved us further as far as deploying and testing and getting these games out to our customers. So what we've been using now for the last month or so, we're using the ExtraHop's tool RevealX, which is where we're bifurcating our packets out to. And what that does is it allows us to reroute the packet that's inside my VPC out to ExtraHop and see what's going on in that packet. It gives us that visibility. The most important things to do that is I can do that without bothering the teams themselves. The deployment teams are going fast and heavy and trying to get this product out. We can do this in a parallel work that adds value back to them, adds value back to our customers, our players. So we're giving a more stable game. We're giving a more predictable game, but I'm not putting in extra overhead, extra latency, anything that slows down the new features, new sets, all that fun stuff that's going on there. And it makes me a partner with my games. It makes me a partner with my studios. So I can give them real information on what's going on right at that moment instead of looking at things from historical And as I said before, the historical doesn't really matter in the space where you're destroying the environments and rewriting and rebuilding on a continual basis. And it moves me out of being the gatekeeper role. How many people here get caught in the gatekeeper role, where you kind of have to say yes or no, or I think, or this is what it looked like? So in the gaming space, that makes you unpopular. I know in the other spaces it does as well. But what's really nice is to say, look, if you can make a change, I can show you that change in the system and see whether or not we fixed it in your next release cycle, which for us is just hours, rather than putting a hard no or a hard impact. And again, we're trying to get these games out as fast as possible. We're trying to make sure that they don't fall over, they don't trip. And this is basically how we do it at Wizards of the Coast. I take all my games, and they're all designed differently. Some back ends are hyper complex, and some are really simple. The games have to build it however they need to build it, but we bifurcate all this stuff into the Extrahoff SaaS solution. My analysts go through and start looking at the vulnerabilities that are coming up. I don't need to be in their scrums. I don't need to be in their meetings. I don't need to review anything with them. What I do need to know is to have the visibility into what's going on in the environment at that moment. Once I have that visibility, what my analysts do is we have a feedback loop into the teams that basically says, here's the actual vulnerabilities, here's the status of your current environment. And you can choose to fix what you can choose to fix, you can modify what you choose to modify, but now you know as a business what our exposures are. Why are we exposed, and then what's the criticality of that exposure? Not what was yesterday, but what's today. And then they can drive that back into their deployment process, update the game. We get the update in our Extrahoff dashboard, and we can say, hey, that was resolved. Well done. But now you have something else. That seems to be the game, right? Now you have something else. So that's what we currently do in our process. And so I'm going to hand this back up to Jim here in just a second. But from our perspective, a lot of you guys don't have the deploy and destroy space. It's a little more stable. But if you're going fast like we are, and you have a lot of eyes on performance like we do, this actually has been a lifesaver for us in getting us out of the way to getting good stuff out there. So thanks, guys.
Awesomeness.
There you go.
Good customer story. Why not? So we're going to give a quick summary, give you a little bit of homework. Won't be that much. Should be fun. What did you hear? Continuous monitoring for sensitive workloads. Now you could take a look and get deeper and quicker visibility to your packets and do the right thing with them. Move them to the tools that you need to. Your first responders can take a look at anomalous behavior and take a look at incidences. Gosh, that's hard for me to say, and respond to them very, very quickly. You're also able to take a look at traffic from multiple accounts. I didn't mention this earlier, but the traffic mirroring solution, the target can be, you could source packets from other AWS accounts. So it's cross-account. And that's pretty neat. And you know, there's a lot of things you can do if you're a multinational company with many different business lines, with lots of different accounts within Amazon Web Services. Awesome, because I mean, you may have hundreds of workloads that span thousands of EC2 instances. So you can do things across AWS accounts. And if you're in a mergers and acquisition type of mode, there are things you can do with that too, to take a look at the company's traffic and see how quickly it would take to normalize it to what your behaviors are. So that's pretty cool. You could deploy and easily manage these devices and subscriptions through AWS Marketplace, cost optimization, tagging, governance, put it in service catalog, make sure that the right people are using it at the right time, and the people who don't need to use it aren't using it. You could also take a look at what's new, because there are things that are new. So don't answer yet. We've got a few things that were announced last week. We didn't have time to put them in the slide, but on November 26th, I guess it was announced that traffic mirroring is now available in Sydney, in Hong Kong, and in GovCloud. So if you're a government agency or a third-party company supporting your government agency or entity, you could now use traffic mirroring enabled tools, which is pretty cool. We've also talked to a lot of customers who are deploying this at mammoth scale, and they've said, getting to every ENI in all my EC2 instances, it's a bit of a burden. So we built a template. It's available on a GitHub. I guess I should have included that link. I'll find it for you if you need it. You can email me and I'll get it to you. But this is a script that will quickly configure the ENIs at scale. So we're making it easier for you to deploy traffic mirroring and traffic mirroring enabled tools at scale. It simplifies the deployment right there. So those are a couple of new things that are out there. Related breakouts. So you can't get to all of these, I get it. But most of these are going to be recorded and they'll wind up on YouTube. So you wait a couple of weeks, search for the session alphanumeric, and you'll find something. These are sessions that are related to traffic mirroring or tangent to traffic mirroring, or they're the next generation of what we're doing with EC2 networking, VPC networking, lots of good stuff. The one that is really fun here is NET402, the second from the bottom. The networking wizards, ask me anything. If you've ever been to a reInvent session with either Matt Lewis or Nick Matthews or both, these are can't miss sessions. These guys are funny, they're super brilliant, you can ask them anything, they probably will have an answer. And if you stump them, they'll probably appreciate it. So that's the one to really not miss if you can get time to do that. Other than that, a hearty thank you. We know it's been a long day already, but thanks for making it out. Please, when you get the chance, go to your app and fill out your session surveys, because it's the way we know how to improve things going forward for reInvent 2020, 2021, and onward. So thank you very much. Enjoy.